Hi, everyone. So this is going to be for the review for the Unit 1 test, and just so that you know how to go to there, you can go here and go to today's lesson plan, right? Review for Unit 1. Or if this is not that week for you and is not located there anymore, the other way you could access that is scrolling up, is go to Modules, and then you wait, and then you're going to scroll down and you go to week. So do you see how these all have the titles of what we did that week? So we're going to go over here to week 3. So then it says Unit 1 review. We're going to go and do that. Click on a thing. Okay, and then from here, these are the things that we're going to be doing today. And if you notice right here, it says review for the unit test. This is where the video is going to be. This is where I'm going to be right here waiting for you. All right. And so you can either download this or you can just click on this magnifying glass to, so that it'll open up so you don't have to like download a thing. Right. And there it is, Jeopardy without the music. All right. And if you notice right here, so I'm going to just go to right about here. I'm going to scroll down. You actually can't click. You can't click on these. These are not clickable because it's a PDF. Right? So sad days. But what we can do, so these are going to be all in order. So it's going to start with the writing functions going all the way down to, see if I could find there it is, the little button. Ooh, shoot. The little button there, so it goes all the way to 500. And our very last problem is going to be this one right here. So that's going to be creating functions. Oh, sorry for the glitchiness of this. So I'm going to go like this, creating functions 500. That's going to be the last problem. So we'll go over a couple of the problems. I'll try to go over some of the more difficult ones. Let's see here. Let's go over this one right here. And always the next problem is going to be the, what is it called? The answer. All right, so what is the function that represents the table? So again, I always like to look at this one right here, right? Anytime I see an x with a zero, x is 0, this tells me the y-intercept, remember? Because it is the y, if we were to graph it, it is the y-intercept, right? So I know that it's going to be f of x is equal to something we're going to do with the x. We're going to probably multiply it with something, and then I don't know what it is, right? And then it's going to be a -1. So if x is 0, 0 times whatever, it doesn't even matter. It's going to be 0 minus 1. So it's going to be -1. All right, so now we're going to have to figure out, I like to use the biggest number because that usually tells me something a little bit more clear. So I'm going to plug in this big number right here. So I know that if I plug in a 3 for x, I'm going to probably multiply it with something. And then I'm going to subtract 1 from it, and that should give me a 17. Well, what can I do to it? I can be like, well, ooh, if I multiply this by a 6, so let me make that in a different color. So if this is a 6, right? 6 times 3, that's going to be 18 minus 1, which is giving me a 17. Okay, so let's see if that's true for the other problem. So I'm going to see here, is this a 6? Okay, so we'll try this. So let's try this for the 2. So if I put in a 2 for, so it's going to be 6 times 2 minus 1. Okay, and that should give me a 7, right? If I go 6 times 2, oh, that's 12 minus 1. That gives me 11, but not a 7. So we know, okay, I'm going to have to do something with that. I gotta get rid of that because that does not work. So it does not work for that. So is there another way to get 17? Let me get my colors in different color. Okay, there it is. Oh, still in erase mode. All right, so then let's see, is there another way to get that? So maybe I go 70, no, what else is there? Oh, how about times it by 3? So times it by the same number, so that's gonna be 9. Times, ooh, what if we do this? So 3 times 2. Let's go back. Go back. So if I go 3 times, so if I go like x times x, right? So if it's x times x or 3 times 3, that's 9, but I want to get an 18, right? So I'm going to multiply that by 2. So 2 times x, right? So that'll be So this would be 2 times 3 times 3. Go 2 times x times. That will give me 18. And then subtract 1, which would be 17. Okay, let's try this. Okay, so here we go. So 2 times x. So it's going to be 2 times 2 minus 1. So that's going to be 2, 4, 8. Ooh, 8 minus 1, that's 7. Yes. Okay, let's try that one more time. So I'm going to make this look a little bit nicer because we know x times x is x squared, right? So it's going to be 2x squared minus 1. And let me try that one more time with a different number. Yeah, so we're going to try that with the ones, right? So it's going to be 2 times 1 squared minus 1. And we're asking ourselves, does that give us a 1? The y, right? So this can be 1 squared, which is 1. 1 times 2 is 2 minus 1. Ooh, yes, that gives us a 1. That's true. Okay, that totally works. So let's just try it just in case, the negative 1, right? So we're going to try that over here. So x is negative 1, so 2 times negative 1 squared minus 1. So that's going to be 2 times 1 minus 1, because remember that's negative 1 times negative 1, which is positive 1. And so that's 2 minus 1, which is equal to 1. Yes, that is true. So it is true that it does equal, I should not put that check mark there. It does equal. Okay, so this is our function. So it's going to be f of x is equal to 2x squared minus 1. That's our answer. All right. Boom. All right, so now I'm going to clear it, clear all drawings. We're going to move on. All right, so we're going to go to the next one. Look at right here. Oh, look, the answer. Nice. We'll just try one more. Oh, we already did this one in class, so we'll not do that one now. Oh, I could make this smaller so I could fit the whole screen. Ooh, did you see that? Use that. That's useful. Okay. Oh, where's the rest of it? Oh, right here. All right, let's do, oh, I think that was it. Those were all the ones. Let's do this one then. We didn't do this guy. All right, let's go. Trying to be creative here, but it's not working very well. I'm gonna try to fit it all in there, which apparently I can't. Okay, there we go. That was difficult. All right, so we're gonna do this one right here. So again, I like to look at the 0. If you don't have a 0, it's a little bit more difficult, right? But it's the same idea, right? You're thinking, okay, what can I multiply? What can I add? Okay, and again, the add could be a subtract, right? But what can I multiply? What can I add? And here I see, oh, this is 0, -3. Okay, we can do this. So it's going to be something with the x. Oh, and I'm going to subtract 3 from it. Okay, so I don't know what that something is. Maybe it's divide. Maybe it's multiply. I don't know, right? But those are usually our two operations we're going to be dealing with. And then that's going to give us f of x. Okay, I don't have a really big number here, so I'm going to just try this 2 here. So if I put in a 2, I get out a 1, right? So I'm going to put a 2 here, and I'm going to multiply it by something to give, and subtract 3 to get a 1. Well, 2 times 2 is 4 minus 3. So the question is this 2 or is it x? I don't know. So we're thinking it's either going to be 2 or it's going to be x, one of the two, because we could do x times x, or we could do 2 times 2. Like it could be, so let's find out. We're not sure yet. So, and again, that's going to be 4 minus 3, which does give us a 1. All right, let me change my colors here to, let's go white. And then let's try not a 2 then. Let's try a 1 right here. Okay, so if I put in a 1 for x, so let's first try 2. So 2 times 1 minus 3. And I should get a -2. Okay, so I'm not sure, so that's why I put a question mark. So that's 2 times 1 is 2 minus 3. Ooh, this gives me a -1. That's not right. Okay, so we know it's definitely not this guy right here. Let's try x then. Okay, so instead of, where's my eraser? So instead of this being a 2, we're gonna have this be, so it's gonna be 1 times 1, because if it's an x, it's just x times x. So x times x, which is 1. So 1 times 1 is 1. 1 minus 3 is -2. Yes. Okay, so this is what it is. Okay, good. So we're thinking we're going with the x, so we're thinking it's gonna be f of x is equal to x squared minus 3. Okay, and we're gonna go with different color here. Purple, we say, just to make sure, because we gotta check. So -2. So if we put in a -2 in there, it'll be -2 squared minus 3, which is gonna be 4 minus 3, which is 1, which is what we should get. We're good. Okay, so we know that this is gonna be it. I would, on a test, I would like check all of them just in case, right? But there we go. Okay, now we're gonna move on to the next section. Clear all drawings, exit out. We're gonna go up, see? X squared minus 3. So we did the tables already. So now we're gonna evaluate. We've already done that one. Let's, ooh, do you see this fraction right here? I see the fraction right there. Let's do the fraction. You're like, yes, please. Will there be fractions? Maybe. Yeah, probably. So here we go. So anytime we see an x, we're gonna put in a 2/3 in there, right? Because this x is here, so we're gonna put 2/3 there, 2/3 there. So it's gonna be 2/3 squared minus 3 times 2/3 plus 2. All right, remember this means 2/3 times 2/3, right? So if you need that little extra help there, right, just like that, minus 3 times 2/3 plus 2. So remember, if it's multiplying, we don't care about common denominators, right? That's only when you add or subtract. We're multiplying straight across. So 2 times 2 is 4 over 3 times 3, which is 9. 4 nines. This one right here, remember, this is like your over, let me see if I can get it. So it's like over 1, right? So remember, we could cancel these guys out because 3's on the top, 3's on the bottom. That's like 3 divided by 3. What is 3 divided by 3? 1. There's 1. All right, so that's just going to be 2. Let me change that back to wide. So that's going to be 1 times 2, which is 2, plus 2. Ooh, minus 2 plus 2, what is that going to be? It's going to be 0, right? So our answer is just going to be 4 nines. You can just put your box like that. Okay, that's all you need to do. Okay, now the next one we're gonna go on. Ooh, probably see clear all, X out. And if you notice right here, yep, 4 nines, just like what we said. So let's do a little bit more. We already did that one, so we'll go. Oh, that was a very big. Ah, this is a good one. So it says the vertex of a parabola is 2, -5, and 1, 7 is a point on the parabola. Find the value of A in vertex form. A couple of things going on here. Okay, I'm going to tell you right now, and the test is not going to be this complicated. Just saying, right? But we know the vertex form right here. So remember, the vertex form is, what is it called again? F of x is we already know A. This is the same thing. I don't know what, let's pretend this is not there. We don't know about this. I don't even know if this is the same thing, so we're just gonna go with that. So the vertex is this right here, 2, 5. So we don't know what A is, but we know that this is gonna be x minus squared. I like to set it up like that. And we're gonna just put in our point, which is gonna be 2 minus 5. Okay, we just need to figure out what x is, what A is. Okay, so we do know that this is a point on the vertex, right? So we're literally going to put, here's x, here's y. So remember, f of x, same thing as y, so we're going to put in a 7 is equal to A, because we don't know A, but we do know x. X is 1 minus 2. We know this point works. We're just going to do order of operations here. So 7 is equal to a times, and simplify that, so that's going to be -1 squared minus 5. And what is -1 squared? 1. So 7 is equal to a minus 5. You're like, where's the 1? Remember, 1 times a is a, right? And then from here, we're just going to add 5 on both sides. And we get a is equal to 12. A is equal to 12. I don't know if you can see that, but that's 12. All right, so we're just going to plug that in. So that's going to be f of x is equal to 12x minus 2 squared minus 5. There we go. Just plugged it in. Don't be stressed out if you didn't really understand that one, because we're going to go over these again, but we technically don't. Actually, I won't say anything. It's good to know. Bye. There's not bye. Okay, so we're going to scroll down. Oh yeah, see, a is equal to 12. Oh, find the height. Okay, this is a good one. All right, so the function of this function here, -16t squared plus 60t, describes the height of a ball over time. How high does the ball go over time? What is the height of the ball after 2.5 seconds? You're like, well, we don't have a graph. We don't need a graph, right? Because remember, what is the height? The height is this is the y, right? And the 2.5 seconds, that's our x. So literally, if x equals to 2.5, what is y? We know how to do this. So we're going to go, so b of 2.5 is equal to -16. You literally plug in 2.5 for all the t's. 2.5 squared plus 60 times 2.5, right? And then order of operations, so calculator, 2.5 squared times by -16 plus 60 times 2.5. And if you have calculators that write it out for you, it knows the order of operations. It's already been programmed with that, so you can do that. Ooh, I get 50. So here we go. So it's going to do, so this is going to equal 50. So what I say is going to be 50, that's a 5. 50 feet high. Okay, 2.5 seconds. There we go, and I'm going to clear that, clear me drawings. And we're going to just scroll down just a little bit. The height, so this would be the better response. So the height of the ball is 50 feet after 2.5 seconds. That would be the ideal situation there. All right, and then we're gonna sketch the graph. Ooh, did we do this one? No. Okay, here you don't have to do your roots, okay, because we didn't figure that one out yet. So if we had factored form. So this one we can't do our roots, but we could calculate other things, right? So that's what we're gonna do. So it says vertex and y-intercept must be calculated, okay? So when it's in standard form or general form, right? This is general form, okay? You could only calculate the vertex and the y-intercept. Okay, and how do we do that? So y-intercept, remember, well, there's nothing really to calculate, right? It's literally just this. This is the y-intercept. So I can just state, if I didn't remember that, then you just like, okay, remember that the x is equal to 0, right? So you can plug in 0 for x and then solve for y, right, to get it that way. And then the other one is, let's do pink. So the vertex, the only way to get a vertex is to do the AOS. And how do we get the AOS? Remember the axis of symmetry? Ooh, I should probably plotted that guy. So here's 0, 8. Right there. AOS is going to be, remember, x equals to -b over 2a. So if you don't remember how to do that, or you didn't write it down, I would write it down. Get like a separate sheet of paper, write those things down. Okay, that's like your notes. You can use your notes. Okay, and so remember, a is going to be the number in front of x squared, which is a negative, so it's -1. B is going to be this 2 right here, and C is 8. So it's going to be x is equal to -b, so -2 over 2 times a, which is -1. And so that's going to reduce down to -2 over -2. What is -2 over 2? -2. positive 1. So our AOS is positive 1. So now we're going to take this AOS and we're going to plug that into this equation, evaluate function, right? We've been doing this. And so we're going to see where the y coordinate is. So it's g of 1. Why is it g of 1? Because it says g of x. So we're using that same thing. So g of 1 is equal to negative x squared plus 2 times 1 plus 8. And this is going to be 1 squared, which is 1. Now that negative has nothing to do with that because negative is not inside the parentheses. So this is going to be negative 1. See that how that one negative just plops right down. This is 2 times 1, which is 2 plus 8. So this is going to be 1 plus 8, which is going to be 9. So our vertex is 1, 9. So we're going to go 1, 9, just like that. Now, we also, so we have the vertex, we got the y-intercept, but how do we draw the parabola? Now, do you remember that I said that, okay, so this is our axis of symmetry. I should probably do that in the same color. I should have drawn this out already, but oh well. So that's my axis of symmetry. And here, remember we have a symmetric point, right? So if it's on the y-intercept, right, it's one unit away from the AOS, which means there's another point on the other side that's 1 unit away. Okay, symmetric point, right? Now we know it looks like it's going down. This is definitely our max here. And so we're just going to literally just draw the line. Oh, shoot. The tip fell out. Go. So we're going to go to this guy right here. We're going to go, it's going to look something. Oh, didn't say that. It's going to cross at the yellow point. Oh, peak at the pink point. Go through. It's going to look something like that. Oh, that's make it look better than mine. Okay, but that's what that's going to look like. That's how you sketch that graph. Okay, do we need to know the roots? No. Okay, all we can do is the vertex and the y-intercept. That's it. Okay, if we have the factored form, we could totally do that. But and I'm going to be looking for this work, guys. If I don't see this work and I just see a graph because you did it on Desmos, that doesn't count. Okay, so you need to show me this. Alrighties, and so let me clear that guy out. Let's do a couple more. Oh, see? Just like what we said. Oh, see, now we can see the roots. They're supposed to be at -2 and 4, but that's fine. If you don't get those roots, fine, that's fine. As long as you get the general shape down, you're good. All right. Oh, here we go. So what if we're given vertex form, right? Then what can we do? So we know the vertex, right? Given the vertex form, that makes sense. And so we're going to go, well, I know the vertex is going to be, it's -3, -2. That's a negative. So remember that this was supposed to be an x minus, right? The only way this became a plus is if this was a -3. Only way. So we know it's at -3, -2. There's our vertex right there. So does it open up or open down? Well, we're like, well, the A right here is positive, right? So we know it opens up. So it's going to go up like this. Well, where's the y-intercept? Okay, it says our y-intercept needs to be calculated. So we know that x is, and we can't just say -2. That's not a thing. That's the only standard form. So we're going to figure out, so for y-intercept, we have to do a little bit of calculation here. So I should probably do this in a different color. So let's do this in red. So y-intercept. All right, so remember it's going to be m of 0. We go and plug in 0 for x because we just want to know what y is when x is 0, right? So it's going to be 0 plus 3 squared minus 2. 0 plus 3 is 3 squared minus 2, which is 9 minus 2, which is 7. All right, so we know that it's going to be 0, 7. That's our y-intercept. So 0, 7 right there. So now remember, with our vertex, we know the AOS, right? That's given to us because the vertex is on the AOS. So we're just going to be like, boop, there's the AOS. Sorry, it's supposed to be on the line, but I'm kind of a little off. And then that means, what does that mean, guys? We have the reflected point. So here, if it's 3 away from the axis of symmetry, it's going to be 3 away on the other side. 1, 2, 3. There is our reflected point. Okay. So it's going to go through. So we can kind of guesstimate it's probably going to be around like -5 or -4.5, something like that, right? So we're going to draw our line like this. Make sure we're going through those points. Oh, that was not terrible, right? But that's what that would look like. Oh, all right, so that's our graph. Okay, okay. So now we're going to clear. If you look, oh yeah, was that the same? Was that the same as what we had? Yes, you're right. Because that's 7. I was like, what? Okay, my brain is, but yeah, that's what we got. All right, so now we're gonna go on. Now we're gonna sketch the function. Oh, we already did this one in class, so I'm gonna just skip that guy. Or did I need to do it again? Let me just do it, just in case. All right, so here we're going to, again, so here, when we're given factored form, we know the roots and whether it opens up, open down, okay? So here, remember, it's gonna be -3 and +1. Those are our roots. Right? It's opposite of what that was, right? Because remember, it's supposed to be x minus instead of x plus. So here you go, -3, +1. Remember, the AOS is going to be, it's like in between. And so we're going to go here. Our AOS is literally in between. So there's 2 units on the right and 2 units on the left, okay? And what we're going to do now is we're going to figure out what the vertex, because we don't know the vertex, but we do know that this is x equals to -1, right? So let's plug it in. So we're going to go b of, so this is the vertex. So b of -1 is going to be -1 plus 3 and -1 minus 1. And so this is going to be -1 plus 3 is 2. And -1 minus 1 is -2. And this is going to be negative, not negative, positive 4, because negative times negative is 4. So our vertex, and if we leave it like this, this is wrong, okay? So this one you need to write it as a point, because vertexes are points. -1, 4. We're going to go over here to -1 and +4. And we can find our y-intercept, right? Because you just plug in 0 for x. And let's use that in yellow. So our y-intercept, I'm going to write over here, very small like. So this is going to be b of 0 is equal to -0 plus 3. And you're like, well, isn't it just going to be 0? I'm like, no, it can't be, because we're adding and subtracting. So that's different, right? So this is going to be -3 times -1, which is going to be +3. So our y-intercept is 0, 3. So boom, just like that. And don't forget, we do have the symmetric point there. So since it is 1 away from the axis of symmetry, it's going to be 1 away on the other side. So do you see how that we could make a much better parabola that way? So it's going to look, ooh, maybe not a better one. It's going to go through all those points, and there's your parabola, just like that. Alrighties, now let's take a look. And again, don't feel like you have to watch all these things. If you know it already, you don't need to watch it. Just skip through. All right. Oh, this is an interesting one. Let's do this one. Maybe there's a reason why I'm going for this one. So the function b of t is okay. We got this ball. We're gonna sketch this graph. Let's do it. Okay. So now this. I mean, I know it looks weird and intimidating, but that's fine, right? We know what to do. This is in standard form, right? Because I notice there are no parentheses, and I have something squared. Standard form. So we're gonna do. We know the AOS. So I'm going to do with what I know, which is x equals to -b over 2a, which means I have to define my a and b and c. So a is going to be the -16, b is going to be 60, and c is going to be 0, because it's not there, right? So that's going to be +0. All right, so now x is equal to -b, so -60 over 2 times a, which is -16. Well, that's going to be -60 over -32. Ooh, what's that going to be? Calculator, help me out. It's going to be positive, that's for sure. 60 divided by 32, 1.875. I'm going to do that exactly, 1.875. So it's going to be x is equal to 1.875. All right, so we're going to go over, oh, I probably shouldn't do it in white because you won't be able to see that. Let's do it in purple. So 1.875, so that's going to be like right, not exactly at 2, like towards the right a bit. Okay, that's about as good as it's going to get. So this is x equals to 1.875. Okay, now we want to figure out what the max is, or the min. Probably the max because this is negative, so it's going to open down like that, so we're going to have a max. So let's do the max in yellow. So again, we're just going to plug this in, and this is why I didn't round it, because if I rounded this, then it wouldn't be as accurate. So vertex is going to be b of 1.875 is equal to negative 16, 1.875 squared plus 60, gonna run into times 1.875. All right, use your calculator. We're gonna go negative 16 times 1.875 squared plus 60 times 1.875 and parentheses. Oh, 56.25. Not terrible. So we get 56.25. All right, so our vertex is going to be 1.875 times, and not times, 56.25. Okay, so if we look right here, I'm going to make this into, let's do that. So these are going by 1, 2, 3. I'm not going to be able to go up by ones on this one, so I'm going to go up by, go to 56. So it's going to be, let's go up by 5. 5, 10, 15, 20, 25, 30, 35, 40, 55, 50. Ooh, let's go by 5, 10, 15, 20, 25, 30. Honestly, I should have just done tens, right? 30, 25, 30. Okay, this is 40. Oh, shoot, 50. And then my 50, 60, about, this is going to be 60. All right, so this is about 55. So it looks like 56.25, so that's going to be like a little bit above that. So like right here at the tip, at the edge of the paper, right? And then how do we find our y-intercept? Plus 0. We're not, remember, it's like plus 0, right? There is no c. If you plug in a 0 for t's, what do you have left? 0. So that's literally it. Ooh, which means we have a reflected point, like a symmetric point, right? How far away is this? 1.875 away, right, from the axis of symmetry, because it's starting at 0. Well, how do I find the other one? Well, it's 1.875 away. So 1.875 plus 1.875, or times by 2. Oh, 3.75. So over here at 3.75, 1, 2, 3.75. So right about here. That's going to be my symmetric point. Okay, so these are symmetrical to each other. Okay, and that's how we get that. And we're just going to, not do that. So it's going to be very narrow and skinny. Try to make a rounded edge and going through those points. Just like that. Okay, and technically it wouldn't go down to the ground because it doesn't go underneath. So I should technically like not have these parts right here. This should not be a thing. It should just stop right there, because if we're talking about a ball, what does it mean if it goes under the x-axis? It's you literally threw it so hard that it went into the ground, underneath the ground. It's like digging a hole, right? We're not doing that. Okay. There we go. And then we're going to go forth and prosper. Oh, look. See? Vertex, what we said. Okay, we talked about that before. Oh, yes. We're like, determine the absolute minimum or maximum of the function. We're like, oh, it gives us the graph. I literally don't care about the equation. It does not even matter, right? And I'd be like, oh, the minimum, I know it's a minimum because it's the lowest point, right? Is right here at -1. So the minimum is, absolute minimum is -1. We don't care about how far left or how far right. We don't even care about that. It's how low can you go, which is -1. Okay, and then if you notice right here, the absolute minimum is -1. See, easy. All right, absolute min or max. Oh, look, that's now a max because that's as high as it's gonna go, right? So we're gonna go over here. Oh, the max is 3. That's it. So we say the absolute max is 3. See, I'll show you. Answer. Absolute max is 3. All right, so now, oh, what are the x and y intercepts? Better know how to do this, guys. If you don't know how to do this, it's sad days. You literally don't even have to calculate anything. Okay, let me do a different color. Let me do green, right? So our x-intercepts right here. So we like x-intercepts at -1, 0, and 2, 0. If you say -1, 2 like this, that's wrong, right? Because that's literally -1 up to, that's talking about this point right here. That's not that point. That is incorrect. Okay, so we're going to delete that guy because that's not a thing. That's not a thing. All right, and then what about our y-intercept? The y-intercept is going to be where it hits the y-axis, which is y-intercept. And if you say, oh, -2, 0, you would be wrong, right? Because the x is 0 and then the y is -2. Remember, it's the x first and then the y, always in alphabetical order. Okay, so that's literally all there is. It's not terrible, right? I don't think. Yep, see, just what I said. We're scrolling, keep on scrolling. Determine the x and y intercepts. Oh, also, is this linear or quadratic? Line, linear. Other one. Oh, come on. Not a line. This is U-shape. It's a parabola. Quadratic. All day long. This is not hard. Okay, and oh, we talked about that one already. Just as a quick review, remember when it's at 16 feet, you go to 16 feet, make sure you get both of these because the graph is equal to 16 2 times, right? So it'll be once going up and once going down, right? Angry Birds, right? And so that's going to be once at 0.5 and once at 1.5. So you need to state those two. Let's see here. Ooh. This is you're listing the properties, right? So, and actually you can just go over them. We already talked about the axis of symmetry, the y-intercept a lot in this video, so I'm going to save a little bit of time. We're going to move on because the answers, I already give you the answers because what are the answers? Well, you'll find out once I scroll down. See, those are the answers, right? And so you could just check and verify. There's, again, some more practice with the features, domain and range. Is there another domain and range one? Oh yes, let's do this. This might be important. All right. So scroll down just a little bit. So our domain is all of our x values. If you see the arrows going a little bit to the left and a little bit to the right, we know that means all real numbers. It's all of them. So we're going to go from -infinity to +infinity. There you go. All real numbers, right? The range, how low can it go? Remember, the arrows are pointing down, which means it can go forever and ever in a day, right? So it's going to be from -infinity. It can't reach -infinity, so we'll just put the parentheses there. And it goes all the way to what? How high? To 3. Could it equal 3? Oh yeah, because there's a point right there at 3. So we're going to put the square bracket, square thingy. Okay, so that's what it looks like. That means equal to. If you want to write it as an inequality, you can go like this. So from -infinity is less than y, which is less than or equal to, let me just rewrite that to -3. Or you could just write y is less than or equal to 3. That's up to you. All right, and then so your interval of increase. So remember, the interval of increase, we're talking about the x's, right? So we're like, okay, so when does it, I'm going to draw my car here. So pretend we have a car. Here is my car, my really weird looking car. Okay, And we always go left to right. So we're always going this, is the car increasing or decreasing? It's increasing, right? Well, when does it start? Well, from negative infinity, right? So it starts from negative infinity. And where does it go all the way up until? Until it hits the wall of the axis of symmetry, right? So until it hits here, which is at 4. So remember the axis of symmetry is a thing, right? Remember at 4 is not increasing, it's like straight across, right? It is neither increasing nor decreasing, right? But right up until then, it's going to be increasing. And then what happens after that? That car is going to come up and then it's going to go down, right? So it's now going to decrease. So it's going to start. So that starts at 4, right? Or right after 4 is what we're saying. And then how long does it go down for? As more, it goes to the right forever and ever, right? So it's going to be to positive infinity. That's it. Okay, so just make sure you, when you flip this up, when it goes like this is now, the left-hand side is now decreasing and the right-hand side is increasing. That gets flipped. So don't get confused. All righties? All right, so we're moving on. Keep on going, keep on going. Yep, there it is for you. And remember, that always gets changed, you know, the y's and the, that uses the x, not the y's, for the interval of increase and decrease. Daily double. Well, we did this one already, so I would do this one if you're still a little confused, and I would check the answers on that. Okay, and then we're going to move on. Oh, yes, here we go. So we did not do this one in class, so this was a good one to do. So if we have, okay, so we're either choosing between factored form or vertex form, but we're going to write an equation. Okay, we're not drawing anything, you know, we're not drawing it, we're just says write an equation. Right, so the parabola opens upward and the x-intercepts are 3 and 10. So we know we're going to use factored form because we got roots. These are roots or x-intercepts, whatever you want to call them. So we know it's at 3 and 10, so we're going to set this up. So we know it's like f of x is equal to, now our a is going to be, it says open upward, right? So if it opened up, we know that has to be positive. So literally, I'm just not going to write anything in there. You could write 2 in there if you want to. It does not matter. So I'm just going to set this up. I know it's going to be x minus, right? And then I'm going to put in my roots. So my roots are 3 and 10. So I'm going to just put in 3, 10. Done. That's it. That's all you got. Nothing else to do. All right. And if you look down, yep. Do you see that? 3 and 10. Now remember that that 2 can be any positive number. So what we did when we didn't put anything in there, that's still a positive. It's positive 1, right? So yeah, totally fine. All right, and we're moving on. We did something like this. Oh, but the parabola opens downward and the vertex. So if I see the word vertex, I know what I'm going to do, right? That's going to be what? In vertex form. So remember, this is my h, this is my k. So this is going to be, I just like using f of x is equal to, if it opens down, remember, down means frown, and it's going to be negative. So I'm just going to put a negative there. X minus squared, and then that's how I set it up. And once I set it up, I'm going to write this down. Let's make it yellow. Remember, this is my h and my k, so now watch what I do. Right, so that's a -6, so that's going to be that negative and that minus, but going to make it a positive. So -6 plus 25, and the plus because that's a positive 25. That's it. We're done. Oh, X out. Okay, now, if you notice right here, do you see how I wrote in 2/3? You could totally do that. As long as it's a negative number, it's fine, right? And then notice right here, it is a +6 and then plus 25. Okay, and then let's see here. Yep, more practice for you. And I think we get to all of them. Oh, this one might be a little bit weird. You might be wondering like, well, why is that? So remember, this is our roots. So we're given our roots, right? And so we have, I'm going to set this up. And remember, it's concave down. Down means frown, right? So which means it's going to be negative. And then it's going to be x minus, let me see. So my roots are going to be 1 and 0. So here's 1 and 0. Now this is the only time you would have to simplify a thing because we actually can. Like x minus 1, we can't simplify that, right? But we can actually simplify the x minus 0 because what's x minus 0? This is just x, right? So what we're going to do is I'm going to put that x in front. So we get negative x times x minus 1, right? Because, I mean, technically, I guess you can write it as x minus 1 times x on the back. But normally we just take the monomials, just the singulars, and just put them in the front. So it's easier to see and we don't miss it. Okay, so this is how we would write that. And that's why on your, clear my drawings out. That's why on here, we have, I put in a -6. You could put in just what we did right here was just put a negative and then x. Again, like if I'm giving you another point on the line, we could figure out what a is, then that's fine, but we don't have that other point. So we're just going to make up a number because we just want any equation that fits that criteria. Okie dokies. And, oh, final Jeopardy. Find the axis of symmetry, the vertex, and the y-intercept algebraically. Here we go. Are you ready? Let's do this. Okay, so remember this is in vertex form, right? So which gives us the vertex. So our vertex is going to be, remember this was supposed to be a negative, right? A minus here. So this is a -2 and +3. Okay, so vertex check. Axis of symmetry, remember our axis of symmetry is on, or the vertex is on the axis of symmetry, right? Which talks about our x value right here. So this is also our AOS, so x equals to -2. And that's an equation because it's a line. A line is represented by an equation. All right, and then our y-intercept, remember, is not 3. Doesn't work like that. If it was in standard form, then it would be, but it's not. So we're gonna have to plug, we're gonna have to do some work. So we're gonna have to plug in 0 for x. So 2 times 0 plus 2 squared plus 3. So you're gonna get 2 times 0 plus 2 is 2 squared plus 3. And this is gonna be 4. So 2 times 4 plus 3. So that's gonna be 8 plus 3. What is 8 plus 3? That's 11. So this is going to be, my y-intercept is gonna be 0, 11. Just like that, all found out algebraically. Okay. All right, I will do well on the test tomorrow, and if you want to look over any other parts, or if you have any other questions, you're like, Leslie, I don't understand this problem, then just email me or text me on Remind, and take a picture of the problem, and then tell me how far you got, and then where you're stuck, and I will email you back. All right, I'll talk to you guys later. Bye-bye.